achọrọ m ịma ayo ịgbagoro gbada achọrọ m ịma ayo ịchọwa ịma na ije na nke ịma ayo ijele ndị Igbo nyapụta gị egwu ayo ezeke ndị Igbo nyapụta gị egwu ayo kedu ọnụ ọra na-akpalite egwu ayo larịga gị ihe ha jikwa
making sure no massa ya bia and I shot them the sabat on the man gala e hangi amen malona baza ya sa basana pasa manga just malona la ta mamba no happy family we me ku kambale abana bonantale na mata makanchale just makana I want jale I say you know the one for me opposite of them bale ya bana me family
Hello, amiable students. In this lesson, we'll be looking at weather. The course objectives are as follows. By the end of this lesson, you should be able to know or define weather, state its elements or variables that constitute weather, and also instruments used in measuring parts or weather components, as well as importance of weather. First, let's look at weather. Weather is the atmospheric condition or a specific occurrence in the atmosphere for a short period of time. This can be state of humidity, absolute or relative, as well as sunny or breezy or rainy conditions in the atmosphere. But when these tend to relatively be permanent for a specific week or month, we refer to it as weather pattern. Weather pattern that have been calculated, sorted, and collected or verified for a period of time of 25 to 35 years is regarded as climate. While climate of 3 specific periods or decades is referred to as climate normal. A change in temperature that affects weather or climate for a longer period, leading to drastic changes in its components or variables, is referred to as climate change. Lines joining places of equal variables are referred to as isoplates. So let's look at the components or parts of weather. The first variable that constitutes weather is temperature, which is referred to as the heat content of the atmosphere, usually the troposphere. This amount of hotness or coldness of the atmospheric condition can be measured with a thermometer. While lines joining places of equal temperature is referred to as isotherm. Temperatures can be affected by altitude. As altitude changes upward and temperature reduces, we refer to this as temperature lapse. While an increase in temperature with altitude is referred to as temperature inversions. The 3 types of temperature lapse that we have are adentic, environmental, and standard temperature lapse. So in referring to temperature lapse rates, we have environmental lapse rate, adentic lapse rate, and standard lapse rate. Moving on to the next element of weather, we have humidity. Humidity is the amount of dampness or water vapor in the air, which can be referred to be absolute or relative. Relative humidity is regarded as the amount of water vapor or dampness that the air can hold with a given temperature before a saturation or dew point is reached that will lead to precipitation. Absolute humidity refers to the amount of water vapor that is totally in the air, whether it can lead to precipitation or not. Humidity is measured with a hygrometer, while lines joining places of equal humidity on a map or on a chart is referred to as isohum. Precipitation normally takes place at the lower part of the atmosphere. So precipitation is the amount of water vapor that tend to fall back to the earth as droplets of water after air has been heated forced to rise after expansion, cools, saturates, and fall back to the earth. So this precipitation can occur in different forms based on the surface temperature at a given time. When the temperature exceeds zero, precipitation are normally in rainfall forms. While it is highly below zero, it tends to come in sleet, snow, fog, etc. Rising convectional current can give birth to rainfall that is regarded as conventional rainfall, while rainfall that are caused by obstacles or geographical barrier on a mountain is referred to as orography. While when two air masses tend to collide or when two air masses meet at a frontal point, it refers or give birth to a frontal rainfall. Air masses tend to describe bundle of air in motion or winds of variable characteristics or variable types. When precipitation is in rain form, it is measured with a rain gauge, while lines joining places of equal rainfall on a chart or a map is referred to as isohyet. Wind is air in motion, or bundles of winds are referred to as air masses. Wind tend to assume its name based on direction and their characteristics that they assume. Wind can be measured in speed and in direction. The direction of a wind is measured by a weathercock or a wind vane, while its speed is measured by an anemometer. The weight of air or wind exerted on the Earth's surface is another type of weather variable or weather element that is called air pressure. Air pressure is measured in millibars with a barometer, while lines joining places of equal air pressure is referred to as isobar. The average air pressure at sea level is 10-13 millibars. So in a meteorological station, all these variables or all these weather elements can be measured to give a definite pattern or a definite scale of weather for a longer period of 35 years that is referred to as climate. So in a meteorological station, radius, Stevenson screen, and other integrated materials can be used to calculate the weather element pattern or weather conditions for a longer period of time.